अस्सलाम वालेकुम रहमतुल्लाहि वबरकातुहू। आज हम जो है वो चैप्टर 2 में फर्स्ट आर्डर लीनियर डिफरेंशियल इक्वेशन को पढ़ेंगे। इस चैप्टर में हम लीनियर भी पढ़ेंगे और नॉन लीनियर भी पढ़ेंगे इंशाल्लाह। तो पहले मैंने आपके सामने डिस्कस किया था पिछले लेक्चर में, हमने जो है वो इनिशियली प्रॉब्लम, यहाँ पे मैंने लेक्चर 2.1 रखा है, यानी चैप्टर 2 का जो है ये लेक्चर नंबर 1 है। तो अगर ये एक्सटेंड होगा तो उसके पार्ट 1 पार्ट 2 होगा, वरना ये सेक्शन है हमारा 2.1, ये चेंज होते रहेंगे साथ साथ। तो इसमें हम जो है वो, जैसे पहले मैंने आपके सामने रखा था कि हमारे पास डिफरेंशियल इक्वेशन है dy बाई डी एक्स, कहते हैं ये फंक्शन ऑफ एक्स वाई, और जब हम इसको सॉल्व करते हैं और हमें पर्टिकुलर सोल्यूशन चाहिए तो पर्टिकुलर सोल्यूशन के लिए हमें कंडीशन चाहिए। हम कहते हैं कि कंडीशन सिर्फ एक पॉइंट पे होगी क्योंकि इसमें एक ही आर्बिट्री कांस्टेंट होगा। तो ये हमारी डिफरेंशियल इक्वेशन है और इसको हम कहते हैं अपनी इनिशियल कंडीशन, और इसको इनिशियल वैल्यू प्रॉब्लम कहते हैं। तो क्वेश्चन इस वक्त ये है कि क्या हर एक डिफरेंशियल इक्वेशन का जो है वो पर्टिकुलर सोल्यूशन एग्जिस्ट करता है, या कोई भी पॉइंट दिया जा सकता है इनिशियल कंडीशन के तौर पे? जवाब है नहीं, ये नहीं है। इसके लिए कंडीशंस हैं, ये जो कंडीशंस को फुलफिल करेगा वो पॉइंट, उस पॉइंट पे जो इसकी डिफरेंशियल इक्वेशन का जो है वो पर्टिकुलर सोल्यूशन होगा, या ये सोल्यूशन ऑफ इनिशियल प्रॉब्लम एग्जिस्ट करेगा। तो वो कंडीशंस क्या हैं? तो उसको ये दो उसमें है इसके लिए। एक तो ये जो फंक्शन एफ एक्स वाई है, इस मस्ट बी कंटिन्यूस ऑन रीजन R1, और फिर इसका पार्शियल डेरिवेटिव लेंगे, पार्शियल एफ बाई पार्शियल वाई इज आल्सो कंटिन्यूस ऑन रीजन, नॉट ऑफ, ऑन रीजन R2। और इसमें जो ये है कि दोनों फंक्शंस एफ एक्स वाई एंड पार्शियल एफ बाई पार्शियल वाई आर कंटिन्यूस ऑन रीजन R। ये इसका हम जो है वो इंटरसेक्शन लेंगे R1 R2 का। अगर ये पॉइंट x0 y0, तो ये कंडीशन हमारी है, इफ़ पॉइंट x0 y0 इस रीजन में होगा देन देयर एग्जिस्ट यूनिक सॉल्यूशन ऑफ द इनिशियली प्रॉब्लम। तो ये इसकी कंडीशन होगी, तब इसको हम कह सकते हैं कि ये इस इनिशियल प्रॉब्लम का यूनिक सॉल्यूशन एग्जिस्ट करता है। इसको मैं आपको एग्जांपल के ज़रिए से समझाने की कोशिश करूँगा फर्दर। इसमें रिपीट करूँगा दोबारा, हर इनिशियल वैल्यू प्रॉब्लम का यूनिक सॉल्यूशन एग्जिस्ट नहीं करता। यूनिक सॉल्यूशन कब एग्जिस्ट करेगा? जब ये कंडीशंस, अगर मैं इसको कर दूँ, दिस इज माय कंडीशन 1, इसमें कंडीशन 2, जब ये दो कंडीशंस सेटिस्फाई करेगा तो इसका सॉल्यूशन एग्जिस्ट करेगा। यानी कि पार्शियल एफ एक्स वाई ये फंक्शन और पार्शियल वाई दोनों को कंटिन्यूस होना चाहिए उस रीजन में, इस पॉइंट को उस रीजन में होना चाहिए। आई विल गिव यू द एग्जांपल and I show you how we can apply that one, the theorem for the existence. This actually theorem is the existence and uniqueness of the solution. So we want to determine the region in xy plane for which the differential equation would have unique solution through the point x0, y0. We want to find the region. We get the initial value problem, we have a unique solution. So the number one is we want to write the equation, the equation in this standard form, so that we can identify fxy. So I can write this one, my dy by dx is equal to ln of 2x over root of 7 minus y. So I get here my fxy. My fxy is equal to ln of 2x over root of 7 minus y. Now here I want to find the partial derivative of the function f with respect to y. We take x as constant. So the derivative we take here, partial f by partial y, is equal to, this is my constant, so I get here ln of 2x partial by partial y of 7 minus y to power minus 1 by 2. I take the derivative of this, we get here ln of 2x into 1.2 into 7 minus y minus 3.2 into derivative of 7 minus y is minus 1. So I can write this one here. I'll get here partial f by partial y is equal to Minus and minus are cancelled. We get 1/2 ln of 2x over root of 7 minus y power 3/2. Now we want to find where they are continuous. They are continuous where they are defined in the domain. With the domain of ln of x, so domain of ln of x is all values of x bigger than 0. And what's the domain of 7 minus y? Here is 7 minus y is bigger than 0. So we get here 7 is, now we get minus y is bigger than minus 7. Multiply 7, we get 7 less than y. Y is less than 7. So we get here these values. We can having here value of y multiply minus, then this inequality will change, and we get here y is less than 7. So here for ln of 2x, we say here fxy is continuous on the region. The region for this one will be R1. You see our region R1 is the function points x, y such that x is bigger than 0 and y is less than 7. So this is my region. We take here the region 2 for partial f by partial y. So partial f by partial y is continuous on the region xy such that x is bigger than 0, because here we having ln of 2x, and here we having 7 minus y again, y is less than 7. We say this is fxy and partial f by partial y are continuous on the region R, and this region, as I told you, that we just take the intersection of R1 and R2. So my R is equal to R1 intersection with R2, and we get here this xy such that x is bigger than 0 and y is less than 7. So I can write here this function. We say that this was number 1, that this was number 1. Number 2 is the point x0, y0 must be in the region R. We show graphically. So this is my x-axis, my x-axis. This is my y-axis. Now here is y is less than 7. So y is less than 7 mean we're having here this y is equal to 7 here. And here x is bigger than 0. So this is the region we are getting here. So the point here in this region, then this initial value problem will be having the unique solution. For example, I take the point x0, y0 in this region. For example, this is 2, this is 5. So this is 2, 5. Yes, it have a unique solution. Either point x0, y0 is equal to -1, 3. No. I have the point x0, y0. The initial condition we defined at the point here in this region is -1, -3. No, we don't have the solution. But we having the solution only in this shaded area. We can have any point x0, y0, x equal to 5, y is equal to -3. Yes, it has the solution because it will be somewhere here. And this is in the region. So we're having the initial problem having unique solution. So we are having the differential equation. Want to find the region where it's having unique solution. So our region is defined. We just find the standard form dy by dx. Then we define a function of xy. We take partial derivative of this one, and then we can see where they are continuous. We say this is our fxy. Fxy is continuous on this region. Here is fxy, and we discuss for this fxy. This is continuous on the region R1, and here we get the values. This ln of x is continuous for all values x bigger than 0. So is x bigger than 0, and this is continuous when y, I just calculated here, y is less than 7, so y is less than 7. So then we are having partial f partial y, again the same function, is x bigger than 0, and this function is also when y is less than 7, then this is continuous. So we are having this, the intersection of these two, R1 and R2, so we get here this region xy set x bigger than 0 and y less than 7. So we just sketch this one here, and we having this value y is 7, and x is all positive real numbers. So we can see it here. This will be have a unique solution at the point x0, y0 in this region R. This is my region R. So we can say if the point, so if we take here as a note, we take this point 1, this point 2, this point 3, this point 4, and we check that it's have a unique solution or not. So is this point is in the region? This 2, 5, yes, is in the region. It has a unique solution. -1, 3 is not in the region. -1, -3 is not in this region. 5, 3 is in the region. So it's having a unique solution. So we take another example. Find the region in which the initially problem which has a unique solution. So again, we write in a standard form. We write here dy by dx is equal to tangent inverse of x over y minus x. Now we can identify our fxy, where fxy is tangent inverse of x over y minus x. I find partial f by partial y. X is constant. We are only differentiating step to y. We get minus tangent inverse of x over y minus x whole square. So that's the derivative of the function we can have here. Now we are going to find the region where it's continuous. We have two functions. One is tangent inverse of x. We know the domain of tangent inverse of x. Domain of tangent inverse of x is our real numbers. This here is from x is from minus infinity to plus infinity. And domain of y minus x will be when y is not equal to x. So we are having the same, both functions. We say the region R is R real numbers such that x is any real number R and y is not equal to x, because when y equal to x, then this denominator becomes 0. So this is the region in which we can have the solution will be. Now we can see here what's the value. We have the value here x equal to 1 and here y is equal to 1 by 2. So here we can see x is not equal to y. This implies initially problem will have unique solution. If we were having here any initial problem, I write the initially problem here. That's here y minus x dy by dx is equal to tangent inverse of x, and we are having the conditions y2 is equal to 2. So this initial problem will not have unique solution because the condition is not satisfied. We have the condition that our y must not be equal to x. So if y is the value, x0 is equal to y0, so then we have seen the condition is y is not equal to x. So here it was y was not equal to x, here y is equal to x, so we say it does not have the unique solution. So there are many other examples. Inshallah, I'm going to upload my notes in our website, and I will give you the access to get that one. So get more example in that, more different example in my lecture notes, and you can see any differential equation book, you can see. If this part is not in your course, you can skip this one. Without any difficulty, you can skip that one. Also, please don't forget that you just subscribe our YouTube channel, and also press also the like button also. So inshallah, you will get the videos when we are going to upload the new videos for you.